Okay, now for the last piece on electric charge and electric field. If we stick a conductor in an electric field, you got to remember charges are free to move in a conductor. If we stick a conductor in an electric field, what happens is charges move to the surface so that the electric field inside goes to zero. As long as there is any electric field inside the conductor, it will continue to move charges until there's enough charge distributed on the outside to completely cancel out the electric field inside. So electric field inside a conductor is zero. The other thing is electric field is always perpendicular to the surface of a conductor. All right. So all the lines coming off of this are perpendicular to it. This leads to some things that kind of interesting. So if you bring an electric field up to a point, right, or if you charge up a conductor, they tend to push things to the point, so you get a non-uniform distribution of charge. This is why we use lightning rods, right? A lightning rod comes up on top of the building, and on top of the building you'll have a nice little point, a little piece of metal just sticking up, right? That is so that if you get excess charge on the building, it really builds up on the lightning rod. Now, why would you get excess charge on the building? You get excess charge on the building because, or you get charge moving here, as a lightning strike is starting to happen, you start getting either positive or negative charges up in the clouds. So here's my cloud, boom, boom, boom. And then on the ground, you have the opposite charge building up. Now, if your house is sitting down here, right, here's your house, and you have a little lightning rod on it, you get, oh, not positive. Let me draw that again. Let's do this all over. You have clouds up here building up positive charge. All right, my pluses aren't fabulous, but there they are. You have the ground down here building up negative charge. Your house is sitting here where the lightning's thinking about striking, but you have a lightning rod. That means you get a bunch of negative charge that starts collecting up here because it's coming to a point. And because of that, when the lightning strikes, it hits the lightning rod, which is grounded, and takes all of that charge and dumps it off into the earth rather than hitting your house and frying your TV. Okay. Yes, frying your TV. Other places where we use electrostatics all the time, a big one is in laser printers. So basically, we use laser printers to charge the charge things on the drum and charge the paper, and then we hit it with the laser light, and it leaves those very nice, sharp images on the paper, right? And finally, inkjet printers. We actually use charged ink and a set of plates. This is basically how TV, a CRT works. We have charged plates that direct the beam of charged ink back and forth so that the ink hits where you need for it to hit. And that's it for chapter 18. I'll continue with the next chapter soon.